Hello my dear friends, I hope you are all fine. In this video you will study about the Faraday's second law of electrolysis. Earlier we have studied about the Faraday's first law, and in this video you will be studying about the Faraday's second law of electrolysis. Dear friends, Faraday's second law of electrolysis gives a relation between the amount of substance discharged at the electrode during electrolysis and the chemical equivalent mass of the substance. Okay. Faraday's second law gives the relation between the amount of substance W discharged at the electrode during electrolysis and the chemical equivalent of the substance E. Okay, and we shall see the statement of the Faraday's second law of electrolysis. It states that when same quantity of electricity is passed through solutions of different electrolytes, then the amount of the substances discharged at the electrodes are directly proportional to their chemical equivalent masses. So my dear friends, in this Faraday's second law, the quantity of electricity that is passed through different solutions of electrolyte is same. So the quantity of electricity is not taken into picture, only the relation between amount of the substances discharged at the electrode and the chemical equivalent masses are related to each other. Okay, when the same quantity of electricity is passed through solutions of different electrolytes, then amount of substances discharged at the respective electrodes are directly proportional to their chemical equivalent masses. If A is one electrolyte, B is another electrolyte, and when same quantity of electricity is passed through these electrolytes, then according to Faraday's second law of electrolysis, Ma is directly proportional to Ea and Mb is directly proportional to Eb. So where Ma is the mass of A discharged at the electrode and Mb is the mass of the B discharged at the electrode. So Me and Mb are nothing but the masses of A and B discharged at the respective electrodes, and E and Eb are their chemical equivalent masses. So we can also put the Faraday's second law of electrolysis in this way. There is a Ma divided by Ea equal to Mb divided by Eb. So this is another way of putting forward this the Faraday's second law of electrolysis. So this can be given in this way: Ma divided by Ea equal to Mb divided by Eb. So Ma is nothing but mass of A discharged at the electrode, and Ea is its chemical equivalent mass. Mb is mass of the B discharged at the other electrode, and Eb is its chemical equivalent mass. Okay, now let us consider one example. If same quantity of electricity is passed through CuSO4 and AgNO3 solutions, you can see here this is a CuSO4 solution, the other one is a silver nitrate solution, and two electrodes are dipped in each of these solutions, and these two are connected in series. So when they are connected in series, you will be passing the same quantity of electricity. So quantity of electricity is not taken into consideration, only the amount of substances discharged at the respective electrodes and the chemical equivalent masses are taken into the relation. So here you can put forward this Faraday's second law for this example, and we can express in this way: MCU proportional to ECU and MEAG proportional to EAG. MCU is nothing but the mass of copper discharged at the electrode dipped in the CuSO4 solution, and ECU is the equivalent mass of copper. Similarly, MEAG is the mass of silver discharged at the electrode that is dipped in the silver nitrate solution, and EAG is the equivalent mass of AZ. So this is the Faraday's second law for this example, and we can also put the other form of the Faraday's second law for this. MCU divided by ECU equal to MAG divided by EAG. That is mass of copper discharged divided by equivalent mass of copper equal to mass of silver divided by equivalent mass of the silver. So this is the Faraday's second law applied to these two solutions of electrolytes. Okay. Now we shall work out the problem related with the Faraday's first law and second law. Three electrolytic cells A, B and C containing ZnSO4, AgNO3 and CuSO4 solution respectively are connected in series. A current of 1.5 ampere was passed through them. 1.45 gram of silver deposited at the cathode of cell B. So cell B is nothing but the silver nitrate solution. How long did the current flow? What is the mass of copper and zinc deposited at the respective electrodes? Dear friends, this problem is based on both Faraday's first law and second law. Now let us write the given data here. So mass of silver that is given 1.45 gram. Then current that is passing through these electrolytes is also given, that is I equal to 1.5 ampere. Mass of copper is required, mass of zinc is required, and time t is also required. Okay. Now first let us find out the equivalent mass of the copper, zinc and silver. So for finding out the equivalent mass, we have to use this formula: equivalent mass equal to atomic mass divided by total positive charge. Okay. Now let us find out the equivalent mass of copper. Equivalent mass of copper equal to atomic mass of copper divided by total positive charge of Cu2 plus ion. So atomic mass of copper is 63.5 unified mass, and this total positive charge of Cu2 plus is 2. So 63.5 divided by 2, that will be 31.75. So 31.75 is the equivalent mass of copper. Similarly, equivalent mass of silver equal to atomic mass of silver divided by total positive charge of Ag plus ion. So atomic mass of silver is 108 unified mass, and that is divided by 1, that is a positive charge of the silver ion. That is equal to 108 by 1, that is equal to 108. So 108 is the equivalent mass of silver. Similarly, equivalent mass of zinc equal to atomic mass of zinc divided by total positive charge of Zn2 plus ion. So atomic mass of zinc is 65.3, and the total positive charge of Zn2 plus ion is 2. So 65.3 divided by 2, that will be 32.65. So 32.65 is the equivalent mass of zinc. Now using these equivalent masses of copper and zinc, we can find the mass of copper deposited at the respective electrodes. Okay. Now according to Faraday's second law, MCU divided by ECU equal to MAG divided by EAG. So we have to take MAG divided by EAG because mass of silver is given here. So we have to find out the mass of copper. So mass of copper deposited MCU will be equal to MAG divided by EAG into ECU. Here ECU in the denominator of the left hand side is taken to numerator of the right hand side, so that will give this equation: MCU equal to MAG divided by EAG into ECU. MAG is 1.45 gram, that is given, divided by EAG, that is 108, equivalent mass of silver 108. ECU is 31.65. So 1.45 into 31.65 divided by 108, that will give 0.426. So 0.426 is the gram of copper that is deposited at the cathode. In the same manner, let us find out the mass of zinc. Similarly, MZn divided by EZn equal to MAG divided by EAG, or MZn equal to MAG divided by EAG into EZn. So here, dear friends, EZn, that is in the denominator of the left hand side, is taken to numerator of the right hand side, so that will give this equation: mzn equal to MAZ divided by EAZ into EZN. Okay, now let us substitute these values. So mzn equal to 1.45. 1.45 is the mass of silver that is deposited, and then EZN is 32.65 that earlier we have calculated, divided by EAZ is 108 that also we have calculated. So 1.45 into 32.65 divided by 1.08, that will give 0.438 gram. So 0.438 gram is the mass of zinc that is discharged at the cathode. So mass of zinc deposited at the cathode equal to 0.438 gram. Okay, now dear friends, we shall find the time of passing the current. So for that, consider the silver nitrate. Silver nitrate ionizes as follows. So silver nitrate gives Az plus NO3 minus. Now AgNO3 contain two ions, Az plus ions and NO3 minus ion. So Az plus ion will be discharged at the cathode, and this 1 mole of Az plus will react with 1 mole of the electron and form 1 mole of the silver. So 1 mole of silver will be deposited at the cathode by gaining of 1 mole of electron by 1 mole of Az plus ion. Okay, so according to this equation, 1 mole of Az plus ion react with or combine with 1 mole of electron and deposit 1 mole of silver. Okay, so according to this equation, 1 mole of Az is deposited by 1 mole of electron, but the charge of 1 mole of electron is 96,487 coulomb. It means that 108 gram of silver is deposited by 96,487 coulombs of charge. Therefore, 1.45 gram of silver is deposited by how much? Okay, so dear friends, we know that 108 is the atomic mass of silver. So 1 mole of silver is nothing but 108 gram. So 108 gram of silver is deposited by 96,487 coulomb of charge. Therefore 1.45 gram, this 1.45 gram is given in the problem. So 1.45 gram of silver is deposited by how much coulomb of charge? So therefore charge required to deposit 1.45 gram of silver equal to 1.45 into 96,487 divided by 108. So that will give 1295.42 coulombs. So charge required to deposit 1.45 gram of silver equal to 1295.42 coulombs. Now dear friends, using this charge, we have to find out the time of passing the electricity. So for that we have to use that formula, Q equal to I into T. So Q is the quantity of electricity, I is the current in ampere, and T is time in second. So Q we have just calculated, that is equal to 1295.42 coulombs. So current is given to be 1.5 ampere. So 1295.42 equal to 1.5 into T. So T equal to 1295.42 divided by 1.5, that will give 863.61 second. So this can also be converted into minutes. So in terms of minutes, it will be 14.4 minutes. So time of passing the current equal to 863.61 second or 14.4 minutes. Okay, so thank you very much for being with me in this video, and wish you all the best of luck. If you have liked this, please share with your friends. Wish you all the best.